In this video, we're going to be covering input and output in C++. So this is part one, where we're going to talk about getting things from the keyboard and putting them onto the screen. Later on, we'll talk about the special case of the string class, string variable type, and we'll also talk about files. Okay, but for this video, we're worried about input. Okay, so the model that C++ uses, a little bit different. It's a stream model. So there are variables of type iStream, all one word, lowercase, that are called input stream variables. And then there are output stream variables called OStream. Okay. So for these, we need to create string variables. So they're their own variable type. Okay. It just turns out that we have predefined, okay, um, in the standard library, we have cin, which is of type input string or an iStream, and we have cout, which is an output stream variable. Okay. And by default, cin comes from the standard input, which is your keyboard, cout, standard output, which is the monitor. Okay. So that's the basic idea there. Okay. So we're going to go through some examples here, just to show how this stuff can work. Okay. So you see here, I'm in my ABC123, which is the test student account. Okay. If I do an LL, you can see that I have made some error here in this io.cpp. I put in the wrong directory. Okay. And this xrice.cpp from one of the videos. So those are not in the right directory. Okay. Because I'm in um, my home directory. They're incorrect. So just as another little bonus on using Linux, I can copy these files. Okay, so I can, from the $sign, I can say CP for copy. It's from to. So I want to copy. If I do star CPP, it's going to move all my CPP files to the directory. Okay, and I don't want a slash. A slash would go back all the way to the home directory. So I leave the slash off and say CSC 1180. Okay, if I do that, and then if I do a CD into CSC 1180, those files are there now. Okay. And one thing I haven't mentioned yet in the videos or anything, if you ever want to go backwards in a directory and get back to your home directory, it's CD space period period. Okay. That takes me to the parent directory. Okay. So now you see I'm back in my home directory. And then if I do a CD dot dot again, I'm back into the home in general, everyone's home. Okay. You see everyone's files are listed there. Okay. But if you ever want to get quickly back to your home, CD space tilde, which is above the tab key, at least on my keyboard, takes you back to your home directory. Okay. And then CD into the CSC 1180 directory. Okay. So now we're going to start looking at these stream operators. Okay. So again, CN is an iStream, cout is an OStream. Those are located in the IOStream directory. So that's why we include that. Okay. We would have to use the std : namespace in front of them unless we type in the using namespace standard. That's why we do all that stuff. Okay. So let's take an example here. I'm just going to call this cex.cpp. Okay. So this is why we always have to include in angle brackets the IO stream, unless our program doesn't have any COs, CNs and COUts, which maybe it doesn't. Most do though. Okay. And then I'm going to have my using namespace standard. Okay. At my int main, at my return 0, and there we go. Okay. So far from what we've been doing pretty basic things. Okay. So we can do a cout, enter a number, space. We have to declare a variable first. So let's say int a. Okay. I can then do a cin with the arrows going the other way with my extraction operator onto a. Okay. And then if I cout a, then that's going to be a basic way to do it, right? Pretty straightforward. Okay. So we've seen that before. So nothing new there. Okay. Some of you figure this out either from looking at the book or just at random. If you have more than one variable, you can certainly do that. So I can do AB. Okay. And I can just string these together. Okay. I could, if I wanted, do them separately, but I can just make one big line. Okay. So let's talk about the CN a little bit more, what happens. So when you call the CN, and it's the CN, it's not the prompt. We wouldn't even need a prompt. It would just wait for us to do something. So that's why we have the prompt, so we know what to do. When you type things into CN, it's going to put them in a spot of memory, which we call a buffer. A buffer is memory, okay? And it's going to be stored in the order that you type it. So if you put 1 space 2 space 3, then that's what's going to be out there in the computer's input buffer, okay? When you do a CN, it's going to take what it can use for the variable type, okay? So if we're doing an integer, it's going to take in up to a space. Okay, so if in this example here, let's go ahead and put in an a space, and B, okay? When I run this, and I'm going to use the shorthand here, so I don't want you to do this to turn in homework, but I'm going to do it. If I just do that, it makes a default executable called a.out. So that's what this is all about. So ./a.out. Okay. When I end the numbers here, 34 and 567, as long as there's a space there, which I can't go back and show you, but you get the idea, there's a space there, then that is going to correctly assign those. Okay. And it doesn't matter how many spaces I have, it's still going to be okay. Okay. Now, life gets more complicated. I've said those were integers. What if I put in 4.5 and 7? Okay. Something interesting occurs. It sets A to 4, but it sets B to 0 because it doesn't recognize this period, okay, as something that it can do. So it's going to get kind of confused, okay? So if you want to allow decimal input, all we would have to do would be change this to a double. Okay, if you do that, everything else should be the same. And now when I compile it and I run it, I can enter whatever I want. Okay, and those are fine. Okay, they wouldn't have to be the same number of spaces. Okay, we're not yet worrying about input not matching up. Okay, at some point we're gonna have to worry about that. But for now, we can just assume the user is doing what they want. Although one thing to consider, it may not work in all times, but if you're going to ask the user to input a number, if you want to not have it blow up and act funny if they enter a decimal place, you could go ahead and make it a double, even if that's not really what you want. And then you can convert it. I think in chapter 2, but it could have been 1. It talks about doing a static cast. So you can change the variable type. Okay. So for example, let's go back to my program here. That's not what I wanted. Go back to the Emacs. Okay. So if what I really want are integers, but I want to cover myself in case the user enters something with a decimal. Okay. So what I could do, I could put in a double called X, for example. Okay. And then each time I do a CN, I'm going to CN to X. Okay. And then I'm going to let A be equal to, it's static underscore cast int. So I'm converting it from what it is to an int. And that's going to take the X. Okay. That will take whatever number was entered here, whether it's a decimal or not. In either case, it's going to successfully convert that to an integer. Okay. Same thing here. So for B, okay, so I can just cut and paste this, get all of this here. Again, that's Control K to kill the line. Keep doing Control K for as much as you want. Move it where you want. Control Y brings it back as many times as you want. Okay. So we're doing our X again. You can make a different variable if you want, but you don't need to. We're going to reuse that variable for B. Okay. So if I run this, now if I enter a 3.456 and say an 8, okay, we're good. It's a 3 and an 8, right? That's what we wanted. We wanted those to be integers. Okay. The only difficulty with this method, I'll show you this if we run it again. What if I entered a 3.9 and an 8.2? Okay. Notice that it converts the 3.9. It doesn't round. It concatenates a decimal portion. Okay. So it's possible in some scenarios that you may end up with a number that's not correct. Okay. So there will be other ways to deal with this. We could put a round in function. We haven't done that yet, but we certainly could. Okay. So that's the basics on CN. Variable type doesn't matter. If it's a character, for example, it just takes one of that. Okay. So we're going to get a little more advanced with CN, but the first thing we have to talk about is how to use functions. Okay. We will be creating our own functions later, but we're just going to be using them for now. Okay. So the example they use, and I'll just go and throw it in this one, is a function to raise a number to another power. Okay. It's called the POW function, the POW function for power. Okay. It is in, so we know that the CN and Cout are in the IO stream library. Okay. They're predefined as I streams and O streams, respectively. Okay. It's the CMath library that has the POW function. Okay. So all I would have to do here, I've done all that stuff. I'll just reuse X again. I could say X is equal to POW. And what number do I want? Let's say I want to take 2 to the power of 8. Okay. If I do that, then after I've done that, I can just see out an X. Okay. If you run this, make sure to always compile. Does that, then gives us 256, which is the correct number. Okay. So when we have this function, so that the POW function is included in the CMath. Unlike in Python, we don't have to prepend it with the math. We just say it. It's there. But this function happens to take two arguments. The first is the number, and the second is the power to raise that number to. They're called arguments, or sometimes called parameters. Okay. And we'll talk more about that when we actually into get into functions, creating them all around. This is using functions. Okay. Okay, so the next thing we're going to talk about is back to CN, and CN has a get function. Okay, and what the get function does, and this is the kind of thing that when you need it, you need it, and when you don't, you don't. It's going to get a single character from the input string. Okay, and this is an example, I believe, from the book. So if we have a character, we haven't used characters much yet, but a character, it gets called an integral type, so it's like an int in some ways, because it's a number that represents a character. So a character here is a letter or number or exclamation point or whatever it is. Okay. So I'm going to see out here just to, enter something. I mean, it doesn't matter at this point. Okay. But then I'm going to start with the cn.get. Okay. And then I send it the variable, and it's going to get the very first thing. Okay. So to put a note in here, I'm going to send the function x space y. Okay. And I want to capture the first character as A, the second character, which is a space, as B, and the third character as the Y. Okay. So I can do a get A. Go ahead and copy those to be able to do a get B and get C. Okay. And then I can just see out A. And again, Control A takes me to the top, Control K, Control Y, enter, Control A, Control Y, enter, Control A, Control Y, and change that to a B and a C. Okay. And that should show, once we compile it and run it, if I do an X space Y, it'll enter the X and the Y. Okay. I could do something different. If I do a 1, 2, 3, it's going to give me a 1, 2, 3. So whatever's there, it's going to take each one. Okay. So something else that we can do with the CN is there's an ignore function also. So the ignore function, so let's go back into here. Okay, I don't think I need any of this. So let me wipe it out again. Okay, so the ignore takes two parameters. Okay, the X is the max number of characters to skip. So the farthest we can go. Okay, and then Y is the character to skip until, which sounds kind of weird. So let's do an example. So we have an int A and B, okay? And our input for this program, so I have to put this here so we can see it, is going to be 25, 67, 89, 43, 72. And on the input, they hit a return. Remember the return's the new line character, the \n, and then do a 12, then do a 78, and then do a 34. Okay. So when we get to this line, okay, and we do a CN A, I don't think I need a prompt. I think it'll just pop up and I can type this. Okay. Then it's going to put into the buffer. Okay. It won't really do this. This is how it looks when they type it. But let's go ahead and put it what it's really going to do. It's really going to put in this new line character, and characters have single quotes around them. Okay. So when we hit enter, it puts that character there. Okay. And we're going to do the CNA, and this is going to set A equal to 25. Okay. We're then going to do a CIN dot ignore, and I want to ignore up to 100 characters or until I hit a new line character. Okay. So that doesn't do anything except advance it forward. Okay. So in this case, after the CNA, I'm pointing right here. Okay. Now start ignoring 100 characters until we get to a new line character. Okay. So ignore, 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 keep ignoring. I'm way under 100 all the way till I get to here. And this quote, single quote, \n, single quote is all one character. This is just how we print it. So skip over that and there really wouldn't be a space there. So now the CN is pointing here. Okay. So it's just as if we entered this. Okay. So then if I do a CN to B, and I'm going to print out A space B and L, which is not in quotes. Okay. And run this. And assuming I didn't make any mistakes, which I haven't made any mistakes yet, so I'm due for one. Okay. So in this one, I'm going to enter a 25. I'm going to enter 67. I'm going to enter an 89. Numbers really don't matter because we're ignoring these. A 43, a 72, hitting enter. Entering a 12, a 78, and a 34. Okay. And you see that, as we suspected, it picks this first number. It ignores all of these up to the new line. It then picks up that one. Okay. The pointer is now in front of the 78. So if I would do one more CN, it would take 78. Okay. So that's all still there. Okay. So the next thing that we're going to talk about is this idea of we don't always know what to do with our input. Okay. So let's say we're going to be going through and using get to get single characters. We want to get a bunch of characters until we run into an X. Okay. And then we want to switch to do something different. Okay. So the problem is, from what we know right now, we can't skip or we can't read something and then unread it. Okay. But it turns out you can. Okay. So we have a couple of commands in Python, or sorry, C++, that we're going to use to be able to do this. Okay. So we have a peek function. So the peek allows us to look at or peek at whatever the next character on the input stream is. Okay. So we can do that. We can save that as a variable, test it, use it. We don't know how to test stuff yet. We haven't covered ifs, but you get the idea. Okay. We can then, if we want, do a CN and actually pull it down. Okay. We can also do a put back, which if you grab a character with CN and it turns out it's not what you wanted, you can put it back at the beginning of the input stack. Okay. So again, I think that the best way to go about this is through an example. Okay, so let's take a look at this. What am I doing? Don't know. I'm losing my mind. Why can I not get where I want to get? There we go. Okay. So again, I think we can get rid of all of this stuff. Notice I'm still including the CMath, but I don't need to. The only net result of that is potentially it's going to make your program longer. This probably has a smart compile and probably doesn't really include it unless you have to, but I'm going to go ahead and get rid of it because we don't need it. Okay. Okay. So the idea here is we're going to have two char variables. Again, take a single character. Going to call it first char and second char. Okay. And we're then going to start here by using the CN. It's the peek function. Okay, so it's a function of the input stream CN. Okay, we're going to do that to peek at the next character that the user inputs. Okay, so we're going to say here first char. If I type it correctly, okay, it's going to be equal to CN dot peek. Okay, it takes no parameters. Okay, then I can see out here that the peeked character is, you put the spaces in yourself, unlike in Python. And we're going to say first char, then indel. Okay. Run this at first, see what it does. Gonna compile it, gonna run it. It's waiting for some input. Okay. So the peeked character is this H. Okay. So just to show that it's not, I don't know what this is doing. That's so strange when it does that. Okay. Just to show that it's not actually removing it from the character, I could go ahead and here and say CN second char. Okay. And then I can just, I'll cut and paste this line. It's most of what I want. Just say character is second char. Okay. I run this. Hello. Notice that the peak character is H, but the character that I'm getting is also H. Okay. So no issue there. Okay. So if we had the ability to test things, if we had our ifs, which we don't know that yet, we could see if this is really something we want to do with that or not. Okay. And then let's say I want that to be the first character. Okay. So I've got this first character. Okay. So the peak character will be H. The first character will also be H. Okay. And we can then, if we decide that was a mistake, okay, I can say CN dot put back Okay. And the put back that I want to put back is the first character. Okay. So I'm going to put that back. So at this point, if we typed in hello, so we'll go ahead and just make a note here so we can track things. The input is hello. Okay. With the peak, it's still hello. At this point, we have ELLO left on the input stack. After this put back of that first char, we have HELLO again. Okay. So if we then wanted to get a second, we could do a CN to second char and then C out first char space second char in line. And we see they're both H. We peaked at the H, okay? Then we took the H. And the reason that's showing up a blank, I didn't change in my print statement the second character. That should be an H also. But I took H as the first character. I put back the H, which didn't change the first character, to put it back. And then I get it again. So I have an H. Okay. So lots of things you can do with that if that's something that you need to do in your programs. Okay. So the next thing to look at is the output. Okay. So with the output, remember that the arrows go the other way. Okay. So let's go ahead and put some ints in here. Have an int A, B. A is equal to 12.345. B is equal to 34.567. Whatever we got there. Okay. These have to be doubles, not ints. Okay. C out, again, I'm going to have the arrows going toward the C out because they're going toward the screen. A space, put B. Okay, that's what we've been doing so far. So I'm going to compile it. Doesn't like something. Well, let's see what I've done wrong there. Double A, comma, B, semicolon, A is equal to. I'm defining it right here. It's very curious. I wonder. So I've got that. I've got that. I've got my int main. Oh, I spelled double wrong. There we go. I wish that it wouldn't have turned it green with that error, but it did. So try it again. Okay, do that. Then we're going to run it. Okay. And you see where it's printing out what we did, right? The 12.3.5 and the 34.567. Okay. So the first thing that we want to do here is let's say that we want to restrict that to 2 decimal places. Okay. And I will say that this acted strangely when I was running through this before I started the video. So we'll see how it goes this time. Okay. So to do this, I can start by doing a C out, and to the string, I'm going to send this set precision. Okay. And then that set precision, I set it to 2 decimal places. Okay. In order to use set precision, and the other things we're going to use here in a minute, I have to include the IO for the input output, manip for the input output manipulator. Okay. And then when I print this, it's going to stay at 2 decimal places until it gets set to something different. Okay. So let's go ahead and run this one. Okay. And you see it sets it to no decimal places at all. That's very interesting. I wonder why it did that. It's so strange that this is giving me inconsistent results because it really shouldn't be. Okay. it doesn't matter that it's on the same line. Let me change that just to be sure. Because it should set it up forever. Then it's set precision to 2. It's giving me no decimal places at all. Huh, try it again. The book talked about some different things that happened with this, and let's see. It's still not showing the decimal place, and I don't have any idea why. My example worked earlier, I promise. It's totally cutting those off. And they're both doubles. They both printed out okay before. I'm just throwing that in the stream. Am I spelling this correctly? PRE. Set PRECISION. Right, it'd give me an error if I didn't. Let's put this at 5. Does that make a difference? And I really can't explain why it was acting strangely before, but we'll see. So it did all that it could. Okay, maybe I didn't compile it. That's possible. Strange things happen. So let's try to set it to 2 now. So that seemed okay. I bet I didn't recompile. We'll see if that was the issue. No, it does not work with 2. Well, let's try it with 3. Sometimes you have to experiment. And you shouldn't. This should be what it is. I don't know why this is behaving this way. Look it up further. Working like it should at the end, so I'm not sure what happened. Oh, it's because I'm stupid. That's exactly why. See, we're all stupid sometimes. The problem is, here's the problem. By set precision, I set it to how many digits I wanted it to be, not how many decimal places I want it to be. That must be what it's doing, which seems weird, but that's clearly what it's doing. So let's see if that is, in fact, what is happening. Because you may not know how many decimal places you're going to have. Yeah, that does that. Okay. Well, this gets used with another function here called fixed. And what fixed does for you is that it makes sure that you have the same number of decimal places, even if some of the variables don't. So let's go ahead and try to put fixed in here. Okay, and see if that does anything for us. Because usually fixed and set precision come together. All right, let's see what this does. File, run, and that does the 4. It's the fix is what we needed. Okay, so put these together. If we do fixed with a set precision of 2, that should be the holy grail of stuff making sense. There we go. Okay, so the fixed with a set precision of 2 is going to set the decimal places the same for all of them. Okay, so that's what that does for you. Okay. Um, and I think a lot of the homework problems ask things to be in 2 decimal places. And when that's the case, just do the fixed, the set precision. And we often do with printouts. Okay, so we can go ahead and if you wanted, you could drop this down like that. Okay, and then do as many of those as you wanted. Sometimes they'll do that for lining things up. Okay. So something else we can do here, we can set up columns. Okay, with the set W, which is also in IOmanip. Okay, and for that we have our 2 variables here. Okay, we're setting up our fixed and our precision here. Let's say we want to do a set width, so a set W for the first one of 10 spaces. Okay, then we do the A, and we don't need the spaces in this case, right? Because we're spacing it ourselves. Okay, and then down there, we can do the set W, let's say 10 again to B. Okay, and this sets up fixed width columns. Okay, so when I do this and run it, Assuming I've got it all correct. Who knows? Yeah. So if you look, and I can't count it out, but if you look, this is 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So there are 10 spaces there, and there are 10 spaces from there to there. Okay. So if we had columns of numbers, okay, we could just continue to do it in this way. Okay. It seems like that once they're set up, I'm not sure if this is true. It's been a while since I've used this. Let's do this again. With that keeping the columns right, I need to set that. No, it does not. So you would need that every time. Okay. So I would have to, when I'm doing the data for every line, put in the widths in order to set things up. Okay. So all of this is going to make your format look better. And we're getting to the point in our programs now, if you want a 10, it's got to look good. And in the homework that we're going to be doing in class, we may have some actually at home for this one also. If you the problems will say what kind of formatting to use, and you need to use that kind of formatting if you want to get full credit. Okay. So the last thing that I wanted to talk about is that in C++, the newer versions, which we're using, it's sometimes difficult if you want to write a number, if it's really long, like if we want to write 1,000,000. Okay, so let's say here we have type long, but doesn't need to be. I could do one, and that's kind of hard visually to see. Okay, but what you can do just on input, not or just when you're typing it, you can't do it if you're doing it from a CN. You can put the single quotes where the commas would normally go. Okay, just to make it easier to read those numbers. Okay, and those would work out just fine. Okay, so that's the first part of the chapter. So there's still more left to do. So there will be a second part of the video, which will be out by Wednesday at the latest. Okay, and as always, let me know if you have questions.